Good evening, everyone. My name is Kazi Anik Ahmed. Today is October 11th, and I'll be doing homework number 5, problem 3. I'm just gonna write my ID, so it's N1546059. I've already done all the problems right now. Just like the last examples, I'm gonna walk through. This is gonna be my video number 1, and I'm gonna walk through problem 3, and I'm gonna go by step of all the steps that I've taken to get to the answer for problem number 3. This is problem number 1, and since I've already done it, I'm gonna switch it back to the problem. This right here. So we are given, from the question, we are given an LTS system which has an impulse response of h of n equals 1/3 of to the power of n cosine of pi divided by 3n times u of n. So we, out of 4 equations rather, we have to find a difference equation that can implement that system. So I've chosen, let's go with B. So y of n is minus 1/3 of y of n minus 1 plus 1/9 y of n minus 2 equals x of n minus 1/6 x of n minus 1. Now I'm going to be taking the z transform. What do I get? It's simple. Y of z minus 1/3 of z minus 1 y of z plus 1/9 z of minus 2 y of z, just from here to here, equals x of n will become x of z. Negative 1 minus 6 x of n minus 1 would be 1/6 z minus 1 x of z. Now let's get here. What I'm doing is a simple step. I'm just getting y of z's by itself in one side and x of z's in the other side, and I'm factoring out the y of z and I'm factoring out the x of z. Now what I'm gonna get is I'm gonna get x of z in this side, and I'm gonna divide this part. I'm gonna move it to the right side. What I want to get is y of z divided by x of z, which is the h of z, or my system response. And then I get this from the top, and this part will go on the top. Now I see that I have a 1/z on the top excuse me, and 1/z square on the bottom. What I do is I divide both sides by z squared. So what I'm going to be ending up with z on the top, and this term will be cancelled out. So that takes me to the second part, which is y of z divided by x of z equals, just like I said, z will be left out, z times z minus 1/6, and this will be my bottom, or my pole. Now simple, zeros and poles. Zeros, this at 0, my zeros are 0 and 1/6, and the poles is just doing quadratic equation. On the bottom, I get 1/3 plus and minus square root 1/9 minus 4/9 divided by 2. By simplifying this, simple algebra, what I get is 1/6 plus minus, since it's an imaginary number, so I get j 1/2 minus 1 radical 1 divided by 3. Now, just simplifying this part, I can take 1/3 common, or factor, 1/3 factor out, and then I'm left with 1/2 plus j of square root of 3/4. Now, the bottom part, 1/2 plus j times this term, I can write it as an Euler, or I can change it. I can write it as cosine of pi 3 plus or minus j sine of pi over 3. Now, if I cross multiply each term with 1/3, I can get 1/3. Now switch it back to Euler in terms of e j omega 3 plus 1/3 times e negative j omega 3, since that sign. Now that is, if you look carefully, with these poles and these zeros, they match on A. So 3b, I've done 3b first. I've gotten the answer for 3b first is A. Now let's see how B is the B for letter A. The first part is the correct equation. From equation y over z x of z, which I got from here, the last page, I can write that as equal to 1 minus z minus 1 divided by third, and multiply that by cosine pi over 3. And this term, I can write it as 1 minus 2z minus 1 divided by 3 cosine of pi divided by 3 plus z minus 2 divided by 9. I'm just multiplying this part and this part by cosine of pi 3. We know that from equation from theory, z of a of n cosine of omega n u of n will equal to 1 minus ac plus cosine of omega naught divided by 1 minus 2a c minus 1 cosine of omega naught, just matching these, plus az of minus 2. Get to the next part. If we write it in that equation, in that formula, we get that we end up getting with the same impulse response that the original system had. 1/3 of n cosine of pi 3 omega n, cosine of pi 3 n, and times u of n, which is the difference equation B. Thank you.